again, finding inverses in section 6.2, we're looking at problem 53, which is f of x equals x cubed minus 1. So our instructions say the inverse is 1 to 1. Find the inverse and check your answer. I'm assuming that to check your answer, they technically want you to do the g of f of x and the f of g of x, but depending on the problem, that can take a little bit of time. So there's other ways to check your answer, like graphing is actually a way to check your answer. So even though the back of the book might be a little bit strict on doing g of f of x and f of g of x, please do that on a few problems, but if it gets like it's too cumbersome and you have another way you can quickly check and just make sure the x's and y's have traded places, then it's good. Okay. So we're going to find the inverse. The way to do that is to trade x and y. Well, right now we have no y, so let's go ahead and rewrite this as y equals x cubed minus 1. And then we are going to go ahead and trade x and y. And you only trade the x and the y. You don't trade any numbers, any exponents, any multiplying, any dividing, subtracting, adding, just the letters. So we just go x equals y cubed minus 1. Do you see how I simply traded x and y? Questions. Now though, in order to make this a function, we want it to be in the form y equals. Right now it's x equals. That's not in the form of a function. So we need to move stuff around to make it into y equals. So we're going to add the 1. So we'll have x plus 1 equals y cubed. And then how do we get rid of a cubed? Cube root. So y equals the cubed root of x plus 1. Remember, when you're doing a square root or a fourth root, you would need to do a plus or a minus at that point. But because it's a cubed root, you don't. Because if it's positive, it's positive, and if it's negative, it's negative. Okay, so we now have the inverse function. Sometimes we call the inverse function f to the negative 1 of x instead of f of x, just to differentiate between the function and its inverse. Okay. Now, in order to verify or check that they are inverse functions, technically we are supposed to do f of negative 1 of x equals x, and f of negative 1 of f of x, and see if that equals x. So we're supposed to plug this into there and plug this into there. So just quickly, at least let's do one of them. Let's do the first one. So that means we would have x to the third, but we're going to plug this in for x. So we would have the cubed root of x plus 1, that entire thing plugged into this x, so that whole thing to the third, and then minus 1. Well, what does the cube do to the cubed root? Cancels it out, so we have x plus 1 minus 1, which equals x. So that verifies. So technically you should also do it the other way around. Now let's graph them both and check to make sure they look like inverses, that the x's and y's have actually traded. So to graph the function x cubed minus 1, it would be the x cubed function, but instead of starting at 0, 0 where that turn happens, it's going to be down 1, if you remember our transformations that we've learned about. So this graph x cubed minus 1 would look like that. Then this one, the cubed root of x plus 1, is because it's a plus 1 inside the cubed root, that's a horizontal shift. So which way is it going to shift? It's going to shift to the left. The plus 1 moves left. So this point moves here, and a cubed root function looks like this, which we memorized those when we did our library functions back in chapter 4 or 3. Yes. Anyway. Now, in order to check to see if those really are inverses of each other, the x's and y's have traded values as long as it's symmetric along that line y equals x. Because that's where x and y would be equal, so if we're trading x and y, then they would go to opposite sides of that line. So in other words, the point at negative 1, 0 should have turned into a 0, negative 1. Wait, did I write that backwards? 0, negative 1 should have turned into a negative 1, 0. Did it? Did the x and y just trade? Yes, they did. Okay, so we have verified this both algebraically and graphically that these two functions are inverses of each other.